Exercise 10.5, question number 1. Students will discuss out here some of the important questions of this exercise. So, question number 1 says, in figure, A, B and C are 3 points on the circle. A, B, C are the 3 points on the circle with center O, such that BOC is 30 degree and AOB is 60 degree. If D is a point on the circle other than the arc ABC, find ADC. We have to find this ADC. So as we can see here, this is 30, this is 60. So this whole will be, this is 30, this is 60, and this point is D, which is on the remaining part of the circle other than the arc ABC. So this is center O. Since angle AOC is twice the angle ADC. ADC. We'll use that theorem. Angle subtended by an arc on the center at the center is twice the angle subtended by the same arc at any point on the remaining part of the circle. The D is the point. According to that, so angle ADC is AOC upon 2. Yes. So AOC is 90 upon 2 is 45. Is 45 degree. Okay. So now the next question which I feel it is important. A chord of a circle is equal to the radius of the circle. A chord of a circle is equal to the radius of the circle. This is the center of the circle. PQ is the chord. OP and OQ are the radius. So this is an equilateral triangle, right? So find the angle subtended by the chord at a point on the minor arc and also at a point on the major arc. Both. So B is the point on the minor arc and A is the point on the major arc. Since the length of the chord is equal to the radius, so it makes a triangle POQ as an equilateral triangle. And students, we know that all the angles of an equilateral triangle is of the measure 60 degree. So angle POQ is 60 degree. POQ is 60 degree. Since if we take this as first minor arc, okay, so this minor arc has subtended angle at the center here. So this angle will be twice the angle which is subtended by this the same arc at this point. So angle PAQ, this implies angle PAQ is the half of the angle which is at the center, is half of the angle POQ. So what is POQ? 60 degree. So it is what? 30 degree? It is 30 degree, right? Now the angle subtended by the same arc on the minor sector. Okay, so this will be the angle subtended by the same arc PAQ now. The major arc we are taking now, considering here. So this is angle POQ in this way. So this is actually the reflex POQ. So angle, we will write here, reflex angle POQ is the twice of angle at the point by the same arc. This point is on the remaining part of the circle. So this is the twice of angle PBQ. So PBQ, this much is 60. So angle POQ will be reflex angle POQ will be 360 minus 60. So 360 minus 60 is 300. Now this reflex POX, we know we need to have this one. So from here, angle PBQ, 2 will come this side, half of reflex angle POQ. So half of reflex angle is 300. So it is divided by 2 to have 150 degree. So in this way, by using the theorem, we can solve more and more questions. Okay. Now question number 9. Question number 9 also is a little bit totally depends upon the figure. Two circles intersect at 2 points B and C. Through B, two line segments ABD and PBQ are drawn to intersect the circles at AD and PQ respectively. Prove that angle ACP and QCD. Okay. Question number 9. Okay. So this is the circle. Okay. Two circles are intersecting. Let me make this figure this side. Question number 9. This is one circle and this is another circle. Okay. This is with center O and this circle is with center O dash. Okay. Now two line segments ABD and PBQ. ABD. This is A. They are intersecting at point B and C. So this is point B and this is point C. So this A, B and D. A, B and D is a line and another line is PBQ. Another line is PBQ. So PBQ, since they need to intersect at point B, so I'll make in that way. This PBQ, this is P, this is B and this Q. So now this was the initial part of the question. This PA and this DQ are actually the arcs of both the circles. Okay. AP is the arc of this circle which is having the center O, and DQ is an arc of the circle which is having center O dash. Now both these arcs are intersecting, both the points of these arcs are going through the point B. So they need to come to the point C also. Now we will join all the points A to C, then P to C, then D to C and Q to C. So this is what actually the figure is. Okay. So since this is the arc, so this angle and this angle, this angle and this angle, this is the arc. Suppose this is angle 1 and this is angle 2. This arc is subtending angle at the same segment in the circle with center O. So angle 1 is equals to angle 2. Angle 1 is equals to angle 2. Here we'll write the reason. Angle in the same segment. Not proper space. That's why I have written here. You try to understand. Okay. So similarly, this is angle 3 and angle 4. Okay. So this is equation number 1, you suppose. Similarly, angle 3 is equals to angle 4 with a similar region. Angle in the same segment. This angle 3 and angle 4. This is arc DQ which is subtending angle C. Both the points are joined with B and C. So obviously they are making angle at B and C both, and they are in the same segment. So both the angles will be equal. Now what about this angle 1 and angle 3? What is the relation between angle 1 and angle 3? They are also equal. Since in the question written that the line ABD and PBQ are intersecting each other at point B. Since two lines intersects, so they make two pairs of vertically opposite angles. So angle 1 is equals to angle 3. They are equal because of they are vertically opposite angles. So now we compare all these three equations. This is equation number 1. This is 2. This is 3. So we have this angle, what? Angle ACP is equals to QCD. Angle ACP equals to angle QCD. So this implies we have angle 2 equals to angle 4, or we can write angle ACP is equals to angle QCD, which is our result. Okay. So you try doing other questions also. I hope the topic and the chapter is clear to you. Thank you so much.